PIC18 USART. Usually to communicate with your microcontroller and other peripherals, some of the protocols are used. Maybe in the form of RS232, SPI, I2C, CAN, and even for that matter USART. Basically, several devices, maybe such as GPS, GSM, RFID, sensors, that needs to get communicated with the microcontroller for transmitting or receiving information. To communicate with PC, microcontroller and several communication protocols are used. Few of them are RS232, SPI, I2C, USART, CAN. The basic protocol is nothing but the set of rules agreed by both sender and receiver. So in terms of how the data packets is being transmitted, how many bits are considered for transmission, and when the data transmission will get begin, and at what time it will end. So PIC18 4550 has built-in USART. Before moving on to this terminology USART, let me just get you to the basic concept for communication. The communication has to get taken place in two different modes: asynchronous communication and synchronous communication. In asynchronous communication, both transmitter and receiver works on different clock. Maybe those are not synchronized at clock as clock is missing into it. So in order to initiate communication, start and stop bits will always be sent with the data. So in order to that, the basic frame structure which is there in front of you is asynchronous communication, where start and stop bits are appended along with the data. So this whole frame format will be transmitted in asynchronous communication. So as to when at the receiver side, this start and stop bit will be subtracted, and after that whatever number of bits will be present, that will be considered as your data at the receiver. Whereas in for the synchronous communication, here both the transmitter as well as receiver both are synchronized with the same clock. And here as they are synchronized over the clock, so there is no need of start and stop bits used in the frame structure. The basic mode of communications are of maybe the category of simplex, half duplex and full duplex manner. Whenever you are saying that mode of communication in the simplex way, in order to that, all the time simplex will be the sender and receiver. The communication will be established only in one direction. So in that manner, if at all sender is wanted to send something after finishing his work, uh, then receiver we can initiate sending some kind of data. So at the time, only one direction communication can be initiated in simplex form. Whereas in for the half duplex form, your sender as well as receiver can act like a sender and receiver. So in that manner, both direction communication will be initiated, and that too with simultaneously at a time. So in that manner, you can consider this in the case of half duplex way. Whereas in for the full duplex manner, this is bidirectional. Sender can play a role of sending as well as reception, whereas in receiver can also play a role of reception and sending with the both the direction. Now, when this terminology comes out in PIC18, this particular communication is enhanced universal synchronous or synchronous receiver transmitter. So PIC18 has built-in EUSART. So these are nothing but most of the common use of USART in to utilize in the asynchronous mode to communicate with the PC, maybe using serial port or using with the RS232 protocol. So in that manner, it is usually been taken care for that. Normally, the rest of the controller have USART. So USART can be configured with the case of asynchronous full duplex communication or synchronous half duplex communication. While is in EUSART, it will simply provide same capability of that of your USART, but automatic baud rate detection will be evaluated with the help of EUSART. So basically, this automatic baud rate detection means every time the rate of transmission will be considered as a baud rate. So automatic baud rate detection means that during the reception, there is no need to set a baud rate at the controller side, and USART will set it by its own, which will certainly take an advantage over your USART. Now this is block diagram for transmitter as well as receiver. The data to be transmitted has to be connected to TXD pin, and the data to be received must be on RXD pin. The whatever data you wanted to transmit, that must be loaded in the data register. So this is transmitter data register. This register is associated with the shift register. So role of this shift register is to shift that respected data serially, and through that you will able to transfer it towards TXD pin. Of course, for the communication purpose, you can enable the synchronous and asynchronous mode of operation using one of the bit SPEN. So in order to that, if at all transmission status you wanted to measure in that manner, whether the transmission is successful or not, either transmission interrupt flag is there, through that interrupt will be generated once successfully transmission is taken place, or you can check the status whether the this particular shift register is empty or not using TRMT bit. Now this rate of communication is being controlled by this baud rate generator. You can set baud rate as a 8-bit as well as for the 16-bit. So this is one of the bit in register which will help you to load either 8-bit rate of transfer or 16-bit rate of transfer. So in order to that, if at all baud rate is 8-bit, only this register will be used. If at all baud rate is 16-bit, then lower byte as well as higher byte. So pair of these two registers can be utilized to set the baud rate. So likewise, data will get transmitted towards TXD pin. If at all you wanted to receive that data on PC, then it is recommended to connect that same TXD pin to the PC's RXD pin. Similar to this transmitter, there is a receiver block. So opposite of this particular transmission is reception. Now here in this particular location, your data is getting received. Whatever data is going to get received, that will be loaded in the buffer register. Again, rate will be again communicated with the help of your baud rate register. So there is a configuration setting to set the baud rate with respect to clock. Now in order to that, again received data has to be loaded in the receiver buffer register. So this is the receiver buffer register. For the asynchronous communication, all the time it is being loaded with the case of start and stop bit and remaining 8-bit of data. So here there is a consideration of in your transmission as well as for your reception, whether you wanted to transmit 8-bit of data or whether you wanted to transmit 9-bit of data. So as per the data size, it will get transmitted and same data will be received towards here. So these 3 bits are nothing but the control bits. So framing error, overrun error, and cyclic check redundancy error. So these 3 error bits you need to check at the receiver end. And likewise, reception is completed, you can display the reception status completed and successfully using interrupt. These are the PIC18 USART register. TXSTA transmitter status register, receiver status register, transmitter buffer register, receiver buffer register, and baud rate control register. These 5 register you can use for programming it with for PIC18 for the communication purpose. Now let's discuss about in detail for these registers. Now very first 2 registers are data buffer register for serial communication. Those are TXREG register, RCREG register. So one is transmitter register and receiver register. Now both the registers are 8-bit register. These are allocated for your PIC18 4550 controller for the transmission as well as reception purpose. So the data to be transmitted has to be loaded here in this register. Let's take this example. If I wanted to transmit good morning data on PC. So with respect to this good morning data, this data has to be loaded in this TXREG register because this data I wanted to initiate for the transmission. This same data towards PC side will be received at one of the buffer register, that is receiver buffer register. That is nothing but your RCREG register. Both the register size is 8-bit. Next, TXSTA register. This TXSTA register is nothing but transmit status control register. This is 8-bit register. In this register, BRGH bit is there. This BRGH bit will simply decide the speed of your asynchronous communication. Now in that manner, if you put this bit as a 0, it will be considered as a low speed. If this bit is 1, it will be considered as a high speed. So in order to that, the formula for the calculation of speed will be taken care. If at all it is a 0, SPBRG baud rate register equals to FOSC divided by 64 multiplied by desired baud rate minus of 1. If at all it is 1, then it is considered as a high speed. So same formula is there except 64 and 16. So in order to that, after the calculation, whatever value you are going to get out of this formula by using bit 0 and bit 1 for this particular speed of communication, that too within asynchronous mode, same value you have to load in this register. So this is your baud rate generator register. Now let's take this example. System clock frequency is given 20 MHz. Baud rate is 9600 bps with low speed. Now as they are mentioning here as a low speed, so this bit has to be 0. Now as this bit has to be 0, then formula will be SPBRG equals to FOSC divided by 64 multiplied by desired baud rate minus of 1. So this formula comes into picture. So as per this formula and the given data, FOSC is nothing but your system oscillator frequency, which is 20 MHz divided by 64 multiplied by baud rate. Required desired baud rate is 9600. So multiplied by 9600 and everything minus of 1. So nearly you will, after the calculation, you will get in value as a 32. Now as this value is 32, in decimal convert this into hex and load in SPBRG register. So this particular above formula will be dependent on whatever value you wanted to load it in BRGH register. As per that, this particular speed will get calculated. So in that manner, this 32 after the calculation convert it into the hex and directly load it into SPBRG in the programming purpose. Now rest of the bits are, let's take bit number 0. Bit number 0 is TX9D, means 9 bit of transmission data can be initiated. So in order to that, you can able to have look upon for the whether you wanted to initiate the 9 bit of data, then this bit has to be enabled. In similar manner, if at all you wanted to set the data frame size 8-bit and 9-bit, so TX9-bit is the particular bit which will help you to select 8-bit of transmission and 9-bit of transmission. So 8-bit and 9-bit is nothing but the number of data bits to be transmitted in one packet. So that decision is done by your TX9. Now, in order to that, TXEN bit will help you to transmit enable bit, which will simply enable the transmission and disable the transmission by placing respected 1 and 0 value into this particular bit. Next is CRC bit, CSRC bit. Now this CSRC bit is by default it is not used in asynchronous mode. So that's why this is don't care in asynchronous mode. While as in for the synchronous mode of operation, it will be considered as a master mode where your clock is generated internally from your BRG register, and if you place this bit as a 0, it will be considered as a slave mode where the clock source is coming from the external devices. So this is the only condition to provide your synchronous clock in master mode or slave mode. If at all it is slave mode, clock is coming from externally, otherwise from your BRG register internal clock will be used. Next bit is sync bit. Now sync bit is nothing but synchronous mode or asynchronous mode detection. So if at all you wanted to perform asynchronous mode of operation, in that manner this bit has to be 0. Otherwise if it is 1, then it will be entered into the synchronous mode of communication. Next is send B. Now send B is nothing but send break character. So in asynchronous mode, send sync break character for next transmission. So every after time it will sends you one break. So if at all the same data will be there, good morning. So every after character transmission it will sends you one break, and it will be cleared upon only by hardware. Whereas in if at all this bit is 0, then it will send only one single break once the whole string will be transmitted successfully. So then and then only it will generate one break into it. Otherwise in this case, every after single character you will be able to receive the break, and once you receive that break you will clear it by hardware and then you will send the next data. Unlike here, whole string will be transmitted. Once it is done, then and then only it will be able to generate break. Next, TRMT bit. Now this TRMT is nothing but transmit shift register. So this will simply check you the status of whether the shift register is empty or not. If it is 1, then your shift register is empty. If it is 0, then your shift register is full. So this is nothing but if at all you wanted to know the status of transmission and reception without interrupt. So more specifically, if you wanted to know the status of transmission, whether it is completed or not, if you don't wanted to look for your interrupt, then you can utilize this TRMT bit. So this TRMT bit will simply specifies you whether this particular shift register is empty or full. So in order to that, when this particular bit is 1, TSR is empty. When this bit is a 0, then TSR will be full. Next important register is receiver status control register. Now this receiver status control register is for the reception status, it will be indicated by using this 8-bit register. Now out of that, SPEN bit. Now this SPEN bit is nothing but serial port enable bit. When this bit is 1, it will simply enable your serial port, and that may be configuring your RxD and TXD pin will be enabled. Otherwise, if you put this bit as a 0, then TXD and RxD pin will be disabled. Next, RX9. So this 9 is nothing but it will select the setting of 9-bit of reception or 8-bit of reception. Always carefully understand this. Whatever setting you will mention at the transmitter, same setting you have to set it for the receiver. Otherwise, what will happen if your transmitter is saying that 8-bit of transmission and here your receiver you have set the setting for the 9-bit of reception. So in order to that, there is a mismatch between your transmitter and receiver. So whatever data size you will specify from your transmitter control register, same status you have to settings you have to do it for the receiver. So this is nothing but selection of 8-bit of reception or 9-bit of reception. Next bit is SREN. SREN is nothing but single receive enable bit. Now this single receive enable bit is disabled in asynchronous mode of operation. Whereas in for the synchronous mode of operation, again there is a master and slave combination over here. In slave combination, SREN bit is don't care, whereas in for the master communication, so in that manner synchronous mode master bit, so this will simply receive as a 0, which will simply disable the single receive. So this will be clear after the reception is completed. At that time only this will be cleared. Next bit is RX9D bit. RX9D bit is 9th bit of received data. In that manner, this can be addressed in the case of the parity checking. So that must be calculated for the one of the extra bit for the purpose of checking the parity. Next is FERR. FERR is nothing but framing error bit. Now this framing error bit can be updated by reading your RCREG register. Now this RCREG register means data to be received, that will be loaded in this register. So in that manner, if at all you have transmitted good morning and in receiver you have received good morning 1-2. So this extra bits are nothing but the frame which you have set. Beyond that you have received data. That could be because of noise. Clear? So in that manner the framing error will be generated, so that user can able to see that whatever specified length is there, beyond that you have received data. Next is CREN. CREN is nothing but continuous receive enable bit. Now this continuous receive enable bit, again there are two options, whether you wanted to operate in asynchronous mode or synchronous mode. So in order to that, for asynchronous mode, it will simply enable the receiver for the continuous reception, and if you put this bit as a 0, it will disable the reception. Whereas in for the synchronous mode, one is nothing but enabling the continuous reception until this particular bit is 0. So in order to that, until and unless you don't forcefully this bit would turn it as a 0, till that time you will be, your receiver will be under the continuous reception mode. Next bit is add en. Add en is nothing but address enable detect bit. Add en is nothing but address detect enable bit. This bit will be used in asynchronous mode where 9-bit of transmission will be enabled. So in that manner, whenever this bit is 1, it will enable the address detection and it will enable the interrupt that will load the receiver buffer when RSR receiver shift register is set to the 0. So in order to that, 0 will simply disable the address detection. So all the bytes are received within the 9 bits, 9th bit, and can be used as a parity bit. So in order to that, this particular parity bit will be considered as a, whenever the detection will be there, in that manner it will be used. For 8-bit of mode in asynchronous mode, this is don't care. Overrun error bit. So this overrun error bit will be enabled when the number of bit size is getting overrun. At that time, the overrun bit will be enabled. It is only cleared by CREN bit, means by using this bit. So by clearing this bit, OERR bit will be cleared, and whenever this bit is 0, there will be no overrun significance will be there. Next is Baud register. This Baud register is baud rate control register. Now in this particular register, only one bit is very useful for the decision upon for the baud rate for communication. Now this BRG 16 bit. So this bit will enable or disable your 16-bit baud rate. When this bit is 1, 16-bit baud rate will be enabled. In order to that, you can use SPBRGH and SPBRG register. So lower byte baud rate, higher byte baud rate. For that purpose, these two registers come into picture. When your baud rate is 0, this BRG 16-bit is 0, means 8-bit baud rate will be used. So only SPBRG register is enabled. In that case, this will be disabled. Now whenever you are using this baud rate, the baud rate calculation will be majorly based upon two bits. One is BRGH bit and other bit is BRG 16 bit. So in order to that, if at all you are utilizing in asynchronous mode, in that manner 8-bit is there, asynchronous mode, where this BRG 16 is 0 and BRGH is 0. At that time, the formula will be FOAC divided by 64 multiplied by n plus 1. Whereas in for this BRG 16 as a 0, but BRGH is a 1 in asynchronous mode, then definitely the formula will be FOAC divided by 16 multiplied by n plus 1. So here the n is nothing but the value to be loaded in your baud rate register, baud rate generator register. So this is nothing but pair. So at that time, again for the 16-bit, the same formula will be used in asynchronous mode, whereas in for the case of the 16-bit asynchronous mode, but this BRGH is 1. At that time, this FOAC divided by 4 multiplied by n plus 1. So at that time, these two bits plays very important role. Now this is interfacing diagram for USART with PC. So just like the one example, if you wanted to send good morning message from microcontroller to PC, so in that manner you require one side microcontroller, other side PC, and the connection between them is done with the serial port. So this is DB9 connector. Out of that you are using only 3 signals: transmitter, receiver and signal ground out of the DB9 port. And in between that, here is MAX232 level shifter, because there is a voltage and current difference between your microcontroller and even towards your PC side. So there is a requirement of level shifting. So that is being done by your MAX232. For flowchart of this UART interfacing, you have to initialize port, input direction as well as output direction. As per interfacing diagram, only 2 pins are used in UART. One is TXD, other one is RXD. So TXD is nothing but output direction signal. RXD is nothing but input direction signal to the microcontroller. That's why you will set the input and output direction setting for your port. After that, you will initialize USART. Now initialization of USART is nothing but setting the control settings for the synchronous mode, enabling the data of 8-bit size, getting the data ready to be transmitted. All these settings with the specified baud rate you need to mention in the USART. Along with that, you need to specify baud rate. As per the calculation, how much is the baud rate now? Baud rate, we have got it in the SPBRG register, and which is nothing but 20. So in that manner, you have to load that setting under the step number 3 of this flowchart. After that, you will initiate your start of transmission. Now transmission will be enabled, and one by one 8 bit of data will be transmitted. So all the time the condition of whether the transmission is completed or not is will be identified either through interrupt or through your shift register, transmission shift register, empty and full status. If it is not empty, then it will check on monitoring that at what time it will becomes empty. And if at all empty, means indication is transmission is successfully completed. At the receiver end, same data will be received because a microcontroller's TXD pin is connected to PC's RXD pin, and PC's TXD pin is connected to microcontroller's RXD pin. So there is a cross connection between TXD and RXD between two nodes. So whatever data you will able to receive, again you have to check and monitor whether the reception is completed or not. So here again you are checking this condition for whether the reception is completed or not. And after that, if at all it is completed, you are displaying the result and you will end your program. So this is your code. As per this code, the problem statement is given that to transmit hello. So you will take one string character. Inside that you will mention your string to be transmitted. After that, whatever functions you have used, that function declaration you have to done it initial stage before your main function. So in main function, you will set the direction as an input and output using the tris bits. So tris c bits dot tris c6 and tris c7, which is nothing but 1 and 0. Whereas in you will load baud rate. What is the baud rate now? SPBRG register has to get loaded with the 20 hex. So load that baud rate. After that, you need to enable your transmission by using BRGH as a 1. So in order to that, your transmitter status register becomes 20. So this particular TXSTA is 20 just because of CSRC is 0. We are sending 8-bit data, that's why it is 0. We are enabling transmission, that's why 1. Sync bit is 0. There we are not sending the every after character break. So we are enabling this after completion of whole string 1 break. That's why it is 0. Low speed BRGH has to be loaded as a 0. TMRT, we are right now not checking the status, that's why it is 0. And as this is 8-bit data, so again TX90 is 0. So like this way, this is binary value, convert it into hex. In that manner, 0, 0, 1, 0 is 2. And all 4 zeros are 0. So that's why you will write here TXXTA as a 20. For this RCSTA, as we are entering into the continuous reception, and in order to that we require to enable the reception. So for that purpose, we are enabling this as a SPEN as a 1. Eight bit of transmission, that's why it is 0. SREN bit is again 0, and continuous CREN bit is 1. As these 3 bits are status bit, and after the particular condition of reception, the status will be updated in the form of maybe the errors. So all these bits are zeros. So all ADN, FERR and OERR is 0. As we are handling the data of size 8-bit, that's why this bit is again 0. So if you carefully observe, this 1001 is nothing but 9 and rest of the bits are 0. So you will set the value for RCSTA as a 0x90H. So like this way you will able to load the continuous reception in RX mode. As you are using Baud as 0 because only the 8-bit of transmission for the serial communication you are taking, that's why Baud register is 0 by putting PIC18 as a 0. Likewise, you will mention one more function as transmit string. So this will simply check you the status whether the string will be transmitted or not in the form of loop. So in order to that, let's say for the transmit byte you will write while transmit status bit dot which status bit you are talking it about, TRMT bit, which is nothing but your shift register. Here we are not using interrupts, but for the completion of status, if at all interrupt is not there, then you can use this TRMT bit. So when this bit is 0, it will wait till the buffer will be empty. So till that time, if buffer is not empty, in that manner it will take the data and load to the transmit register. And in order to that, for the receiver status string, in that manner you will able to receive the interrupt flag till it becomes clear, it will be able to receive the data. Now, if at all you wanted to display that data, you can load that data into your RCRBR register to some of the variable and you can display that variable. So like this way, if at all number of characters are more in your string, you can take a help of your string pointer. So until your pointer becomes null, it will transmit the data to the transmitter and receiver able to receive it. So here in your MPLAB IDE, you will create one project for serial communication for baud rate 9600, with which you will write the same as per the algorithm to transmit that hello string. So in that manner you will write the same functions with the main and transmit function, along with that the setting for transmitter as well as for the receiver. After that you will build this code. Once you build this code with the help of programmer, you need to select PIC18 programmer. So by clicking this PIC18, your PIC18 will be enabled, and once you run that particular program, so executable file will be burned with the help of PIC18 on physical hardware.
So for UART interfacing, you require PIC18 board with PIC18 and one more RS232 cable you require. This cable, one end is connected to RS232 here on this PC, on this kit, and other terminal is connected to PC. So let's connect one end here. Other end for this cable is already connected to the back end of the PC which you have taken it for programming. Now as per this particular interfacing diagram, RX and TX has to connect it to this serial interface. So MAX232 level shifter is being connected over here, and DB9 connector you are connecting to the PC. So here RC6, RC7 means these two pins. RC6 and RC7, those are connected to the line, respective line of TXD and RXD. So RC6 is TXD, RC7 is RXD. Along with that, two more pins are required, and that are VCC and ground. So from this particular port C, I have taken VCC and ground. Along with that, I have taken RC6 and RC7. After this connection, You have to burn that respected hex file on hardware with the help of PIC18 and MPLAB. Once successfully done with the loading of that hex file on microcontroller, just press reset. Output of this particular practical will be displayed on serial monitor. So once you press reset, output will be displayed on serial monitor. So here is putty terminal. So this putty terminal is serial monitor terminal. You can able to see it here in the putty terminal. You can able to assign with your all the messages. So first message, hi testing, USART testing code. Now I will send the 10 characters to microcontroller. Using keyboard, system keyboard, I'll be using 10 characters to type. After that, press enter. So these are the characters which I have typed, and these have successfully transmitted to the microcontroller. So like this way, your transmission and reception will be taken place with the help of microcontroller PIC18 and PC.